If you ever had taken a bath in a bathtub and your mother lets you bring toys during bath time, you would more likely have a toy submarine. But today, we're gonna talk about the real submarines, the bigger ones and the cooler ones. Ever wonder how something as heavy as that floats and sinks? To answer that question, we should ask our friend Archimedes. Back in 246 BC, it was Archimedes' bath time. But when he was about to enter the bathtub, water starts flowing out. You know, if that happens, you would just take a towel and wipe it, right? But not Archimedes. He wasn't like other people. He created his own principle based off that experience. Seriously, just get a towel, man. Someone's gonna slip. His principle goes like this. An object which is partially or fully immersed in the fluid will experience a buoyant force equal to the weight of the fluid displaced. In simpler terms, when you place an object in water, the weight of the water that is displaced is as strong as the buoyant force. It even has its own formula. How to determine whether an object will float or not is by comparing the weight of said object and the weight of the dispersed water. If it's the same, the object will float. If the object is heavier, the object will sink with acceleration. And if the buoyant force is stronger, then vice versa. Now we got that out of the way, time to actually start talking about submarines. As you can see, the submarine floats even though it weighs a ton. Ever wondered how? Well, to find out, we gotta cut it in half. As you can see, the submarine has a secret hollow tank in it. These tanks are called ballast tanks. They're full of air and have valves in it. When the submarine is ready to dive, these valves open, letting water in and air out. The weight of the submarine increases and surpasses the buoyant force, thus allowing it to descend into the watery depths. It will keep descending until the weight of the submarine and the buoyant force is equal, which then causes it to float in place. After spending a lot of time with our fishy friends, we will want to go back to the surface. So how do we accomplish this? Well, every submarine has an air tank, because we kinda need to breathe. We use some of that air in the air tank to push the water out of the ballast tank. This will make the weight of the submarine less than the buoyant force, thus it will start to resurface. When making a submarine, if you ever decide to make one that is, there are plenty things to consider, like the shape. You want it to move fast, right? Imagine how boring it would be if it was slow. So the suitable shape is a streamlined shape, so it will reduce the water resistance acting onto the submarine. Now, how about the materials for the body of the submarine? You're going to dive deep in the water. Buying dollar store cheap materials for your submarine isn't gonna cut it. You need strong materials so it can withstand the high pressures at the deep depths. And of course, the rate of rusting of said materials need to be low so that it doesn't rust. You would be submerged in water after all. You would also need components which enables the submarine to rise and sink. If you were actually paying attention, which I hope you did, you would know these components are ballast tanks that can increase or decrease the weight of the submarine for it to sink or float. And last but not least, you will need a power source if you actually want to operate the submarine. It has to be a nuclear reactor. You don't know how long you'll be underwater, and a nuclear reactor can last long. Just make sure it's stable though. Uh-oh.
Are you okay? Are you okay?
Besok ku makan lagi.
Me too.